Alrighty. I'm gonna do 4-5 and 4-6 today. I don't think either of these will take long. How's homework coming along? Good. We're getting there, making progress. Okay. Um, we've hit midterm. I turned in grades last week, so I don't know when those post officially, but it should be pretty soon. Um, if you're not happy with your grade, talk to me. There's stuff we can do. If not, keep doing what you're doing, I guess. Cool. Yeah, let's do things. Sorry, it's been a long day. Tired. Are you going to be playing this game? Are you actually going to like do math? Okay. I love that you begrudgingly said that you were going to do math. Makes me feel great. Actually, I don't care. Alrighty, it's math time. Um, 4-5 is a weird little one. Linear approximation and differentials. So this is another holdover from time long ago, I feel like. Now that we have calculators to do these linear approximations, easy. But I suppose we didn't always have that. So we have formulas to help us with this. Let me give out our formulas and then we'll use them. Where did they go? There we are. All right. So say we have a function and we want f of x. X, we're going to eventually plug something in for that, but we'll get there. This is approximately L of x, and this formula says take f of a, where a is something close to x, plus f prime of a times x minus a. Okay, so our A is going to be something very close. We could overshoot it, we can undershoot X, but it's going to work out nicely. So this would be like if we wanted to find the fourth root of 31. I mean, like we can throw that in our calculators and find it, but we also know that, hang on. The fifth root of 31, sorry, undershot that one. I know that 2 to the fifth is 32. So we're going to use as our test point, our A is going to be 32 instead, and we would plug that in, but we'll do that in a minute. If we want to approximate the change in Y, so approximate our delta Y, and this is our differential, it's F prime of A times our change in X. So the change from X to A. All right, let's say mark a good example. Lost my formula there. Scoot this up a little bit. Okay, so we are going to use our formula to find the linear approximation of square root of 1.1. We know it's going to be 1-ish, but let's be a little more formal about it. So our equation, L of x, I'm going to just rewrite what we have up here. It's my equation. All right. We know f of x. What's f prime of x? Yep, take 1/2, bring it over, clean it up. That's what we get. Okay, so in this example, our a is 1. So that's the nice value. We know the square root of 1. We don't know the square root of 1.1 necessarily. So we're going to use this. F of 1, our f is root x. So root x of 1 plus f prime, which is this guy here, to square root 1 times our x value, they give us this backwards, our 1.1 minus, we're going to use a equals 1. Make it a little nicer. Okay, this should be easier to calculate. The square root of 1 is 1. The next piece will give us 1/2. 1.1 minus 1 is 0.1. And I think this is good. I didn't. 0.05. Yeah. So we estimate that the square root of 1.1 should be about 1.05. Let's see. Throw up my calculator and I get 1.0488. That's pretty close. So our estimation works pretty well. Did I use? Circled a few. Okay, same formula. Don't forget this guy. I keep forgetting this formula, so I'm going to rewrite it down. And let's say our function is the cube root of x, which we can rewrite as x to the 1/3. And we want find the cube root of 2 and find the cube root of 26. So we're going to do this 2 times. The hardest part, in my opinion, is deciding what number to use for our a. So we're going to break this into 2 things. What is a number that's close to 2 that has a nice cube root? Well, if we undershoot it, 1 works. What about the next biggest thing that has a cube root? Well, 1 times 1 times 1 is 1. We go to the next number, 2 times 2 times 2 is 8. Is 1 or 8 closer to 2? 1 is. So for this one, we're going to use our a as 1. Okay. We're gonna need f prime of x for both of these. That's going to give me 1/3 x to the negative 2/3, which we could think of as 1 over cube root of x squared. That's how I'm gonna, oh, times 3. Okay, we're gonna plug this in. So L of x equals my f of a. So my a is 1. I'm going to say cube root of 1 plus f prime of 1. My x value is 2 minus 1. Clean it up. I get approximately 4/3. Like our end value should be 4/3. I throw it in my calculator. I get 1.2599. Pretty good estimate. So I'm doing the linear approximation, throwing it in our equation, then I'm checking, this is the calculator. Do they match? Are they close? If they're close, cool, we're done. We've got it. We don't have to do anything more with it. Okay. Cube root of 26. Any thoughts on what A should be?
Good. 7.
So A shouldn't be 3, it should be 27. Yeah, I see where you're going with that, but our A needs to be 27.
26.
Yes. Yeah. So if we throw 27 in there, 27 has a nice cube root, it's 3. So our A is going to be 27. Fill it in, do your thing. I'm going to find another problem circled already. Forgot about, there we go. So throw everything in my equation. We funnily enough get 3 plus or minus 1 over 27. And that gives me approximately 2.96. I plug this cube root of 26 in my calculator, and I got 2.9625. Big, fat, happy face. Yay, it's close.
27. Yeah, you got your 80/27. Yeah, don't do the calculators to do that.
Oh yeah, I did. I just took 3 minus 1/27. And I threw it in my calculator because I don't know, I could. I didn't want to multiply 3 times 27 and then, common denominator, blah, blah. Yeah.
That's all.
Alrighty, do you want to try some yourself on your lonesome? Okay. So use this formula to find, oh, I only circled 2. I was being nice. Find the linear approximation is what I'm saying in here. Okay, so thing 1 is to figure out, well, you see your formula, like your f of x is there. Figure out what your a should be. And if it's between 2, try both, see which one's better. I'm gonna pause the video. Whoops. Maybe. Okay. I bet I can fit both of these on the screen if I'm careful. Where's the halfway point? There-ish. Okay, so for our first one, what should our A be? Good choice. All right, so my function is root x. We've already done one like this. We get 1 over 2 root x as our derivative. So we say L of 146 equals square root 144 plus 1 over 2 root 144 times x minus a. 146 minus 140. So I get 12 plus 1 over root 144 is 12 times 2 is 24. And we have a positive number this time, which equals 12 plus 1/12. And I'm gonna calculator that bad boy. I get roughly 12.08. Did anybody attempt the actual, the root 146? So very close. Good. Works out. All right. For E, what's our A value?
Value 6. Right now.
Yes. Yeah, that's our X. Yeah, 0's really close to that. I can't think of anything better. So 0 is perfect. All right. Our function then is e to the x. The derivative of e to the x is e to the x. So L of 0.06 equals e to the 0 plus e to the 0 times 0, nope, times 0.06 minus 0 gives me 1 plus 1 times 0.06, which is 1.06. No, that seems right. Okay. Yeah, okay, that's good. Plug it in my calculator, I get something really close. So showing us that these values are pretty close each time, so they're working out nicely. Okay, the next piece of what we have today is a little bit longer, but it's not terrible as theorems go. Let's put this over. Okay, screen, there you go. 4.6. We have the mean value theorem. So the first theorem we're going to look at is actually a special case of the mean value theorem, I think. We can get one of them down. Both of them are pretty straightforward. This is called Rolle's theorem. And this says, let F be continuous on a closed interval A to B. Yep. And differentiable on the open interval. With f of A equals f of B. Then there is at least one point C in our interval such that f prime at C equals 0.
Some of the squeeze theorem, or am I just off on that?
You're off on that, not the squeeze theorem. That's for limits.
Okay.
It's not limits. No. So get that down, and then I'm going to draw a picture of what we're saying. Actually, I'll start my picture now. Okay. We have a function that is continuous on our closed interval A to B, and it's differentiable on the open interval. We don't care about the endpoints because they won't be, but on every place else, it's differentiable. If f of A and f of B is the same value. So if we plug it in, plug in A, we get a Y value, plug in B, we get a Y value. These two Y values are the same. Then, let's do the simpler version. We have at least one place along this function that its derivative is 0. So it either flattens out, it changes directions, it does something, because it always comes back to itself, even if it goes here, goes in a crazy route, back down to here, it has to change directions. Oops, no, bye. If we have a constant function, then yeah, we have a C value in there where its derivative is zero, it's C values. So really it's saying, hey, if it comes back on itself, we're gonna have a flat place at somewhere. Let's do an equation where we can look at that. Hopefully everybody got that. So our function f of x equals x to the third minus 7x squared plus 10. So let's come up with an interval. Let's kind of graph this and see what it looks like. And what interval do we want to find? Actually, I'm just going to give you the interval. Let's make that a little easier. On the interval 0 to 5, we're going to verify Rolle's theorem. So plug in 0. What do we get out? What's f of 0?
0.
Yeah. Probably, but we should probably check it too. You make me do it, aren't you? 5 to the third minus 7 times 5 squared plus 10 times 5. Hey, it is. Woohoo. Kind of figured it was going to be. Okay. So Rolle's theorem says there's at least one place along this interval where we're going to get a derivative of 0. Go forth. Find me derivatives where they are 0. All right, I take the derivative and I look at that. Does it factor nicely? I don't think it's going to. Six. It does not factor nicely. So we cry a little bit, and then what do we do? E squared minus 4AC all over 2A. Clean it up. Okay, 14 squared minus 4 times 3 times 10. I get 14 plus or minus root 76 over 6. Take the square root of that thing. gives me 14 plus or minus 8.7178 all over 6. Yeah, we can find 2 points. 14 plus that plus 8.7178 over 6.